Here we have a series, and with this trig function we know that the values of sine are going to range between -1 and 1, but it's not going to go term by term, because if I put a 1 in here I have the sine of 2, then I have the sine of the next one I put in here with the 2, the sine of 4, and so forth. And sometimes those are going to be positive and sometimes those are going to be negative, but not in an alternating pattern. However, if I look at the series that is the absolute value of this series, so I can put an absolute value on here, sine of 2n over 3 to the n, and if I determine convergence of this, if I get that this converges, I will have absolute convergence, which implies convergence of this other series. So let's have a look and see what we can find out here. So I actually could take these terms and compare them to a known convergent series, because I could have the absolute values on the numerator. I know the denominator is positive. The largest this will ever be is 1, so this is going to be less than or equal to 1 over 3 to the n. Well, and actually when I look at this I could do this as strictly less than, but we'll just leave it. It works either way. But since I am only going to be doing even integers, because I put in a 1, then a 2, then a 3, the only time the sign would ever be 1 is if I had pi over 2 or plus 2k pi, and that's not ever going to happen when it's on these even integer values, so I could do a strictly less than. But anyway, by the comparison test, because this is a geometric series with the common ratio being 1/3, it converges, and it is all of the terms of that are always greater than or equal to the terms of this series, and so I know that I have absolute convergence, which implies convergence. So I have convergence of the original series.